Hi everyone, this is supplemental to the instructions that are already in Brightspace. So several people emailed me and were kind of confused on the 4.2 online homework. So I wanted to work through one completing the square problem with you. So the first thing I always do is I take this constant, in this case it's a -8, and I put it to the other side. Okay, so of course we have to do that to both sides, so we add 8 to both sides. Okay, so I'm going to have 2t squared minus t, and then notice I'm leaving a blank there. And then I have equals 8, okay? So one rule about completing the square is that this coefficient, the coefficient of your squared term, needs to be 1. Obviously, it's not 1 in this problem, it's 2, so we can simply correct that problem by dividing everything on both the left side and the right side by 2, okay? So again, as long as you divide both the left side and the right side by the same thing, then the truth value of the equation does not change, okay? So at this point, I should have t squared minus 1/2, oops, sorry, there's a t here, equals 4, okay? So this right here, we'll call it b, right? This is our key to completing the square. So right now, b is equal to 1/2, okay? So first, we're going to take b/2. So what is 1/2 of 1/2? Well, or sorry, -1/2. It's -1/4. Okay, so first we find b/2. Then what we do is we take b/2 and we square it. Notice that it's always going to be positive because a negative times a negative is a positive. So in this case, and I'll use a special color, let's use green here, this is going to be positive 1/16. Okay, so that's how we are going to complete the square here. Okay, so we are going to add 1/16 here, and then we're going to add, 1/16 there. Okay, notice if I do it on the left side, I have to do it on the right side, or else the truth value of this equation does not hold up. Okay, so now this guy is what we call a perfect square trinomial. Okay, we did that on purpose. If you go way back to, I think it's like chapter 1, when we were factoring polynomials, we learned about perfect square trinomials. If you want more information and want to understand it more, I can link you to the 082 textbook where the concept is originally introduced, or maybe even 081. Okay? No, it's 082. It's definitely 082. Okay? So this is a perfect square trinomial. So by definition, okay, I can factor this guy out by saying that it's t, and then what goes here is going to be whatever b/2 is. In this case, it's -1/4. And then it's t minus 1/4, okay? And of course, I can be lazy, and I can rewrite that as t minus 1/4 quantity squared, okay? If you don't believe me, if you don't believe that you can factor out this trinomial in this way, remember, you can FOIL, okay? You can prove to yourself, right? If you write t minus 1/4 times t minus 1/4, you can do first, outer, inner, last, and you can prove to yourself that that really is true. Okay, so again, that's the whole reason we went through the silliness of adding 1/16 to both sides was to deliberately construct a perfect square trinomial. Okay, so then over here, if you can buy the fact that this trinomial factors to t minus 1/4 quantity squared, then over here we have this nasty thing where we have to add a whole number and a fraction. So this definitely goes back to 081. We need to change 4 into a fraction. So this becomes 64/16. So 64/16 plus 1/16. Okay. As you can see, I'm a little bit sort of out of room here. Let's see, where can we put this? I guess I'm going to have to erase this to make some room here. Okay, so I have t minus 1/4 quantity squared is equal to 64 plus 61 is 65/16. Okay, now this is the part of the show where you have to take the square root of both sides. Remember, when you take the square root of a square, you have some ambiguity. You could have a plus solution or a minus solution. Okay, so the square root of 65 is some irrational number, but of course the square root of 16 is just 4, which is really nice for us. Okay, so from here, if we add 1/4 to both sides, and I apologize, I don't have room to show that, but just believe me, what I'm doing is adding 1/4 to both sides. I get t is equal to 1/4 plus or minus the square root of 65/4. Okay, so the next thing I want to talk to you guys about is typing this into my open math, because that was what most of the emails were about. Okay, so let me go to the next page here. So again, we have t is equal to 1/4 plus or minus the square root of 65 over 4. Okay, so my open math, for whatever reason, I don't know, like I didn't write the program for it, doesn't like the plus or minus, okay? And plus or minus actually means that there's two solutions here. There is a plus solution and a minus solution. So what my open math wants to see is it wants to see something that looks like this, and then they want you to separate the next thing with a comma, and then they want something like that, okay? So this is what my open math is hoping for and looking for. And for whatever reason, guys, I didn't write the code for this, but for whatever reason, it's not going to take this answer. It's going to be like, nope, that's wrong. Of course, if it was a paper test and I was grading it, of course I would mark it correct. My open math is not going to. Okay. Just one more thing here. This is absolutely correct. My open math should take it. You might notice that both of them, the 1/4 and the root 65 over 4, have the same denominator. So another algebraically valid way to write this would be 1 plus the square root of 65 all over 4. Now, the tricky thing is if you want to type that into my open math, right, it gets a little bit hairy. I think you have to click on the fraction button, or I believe the other way to do it would be to put this in parentheses, okay? If you just put in 1 plus, the square root of 65 over 4, hopefully you can see that is incorrect because the number is 1/4, not 1. Okay, so we want to be careful that we don't do that. Okay, but again, if you were able to group either with the longer line of division, or if you're able to group using parentheses, this should be an equally correct way of entering your values into my open math.